Hi, my name's Allie and I'm a high school senior. I'm super excited about GETT's new video series. I've loved GETT over the past few years, especially the expo. My favorite STEM subjects are biology and chemistry, which I plan on studying in college. Happy 20th anniversary, GETT!
Hi guys, I'm NBC10 First Alert meteorologist Crystal Cly, and I'm so excited to still take part in this year's GETT event with all of you girls. Even if it's virtual, we can still make things fun. Just a few years ago, I got to meet some of you as a participant in the event, and this year with our virtual plans, we thought, why not talk weather with a really cool experiment? So hopefully you'll enjoy and learn a little bit about weather. Take a look. Hopefully you have everything you need for this experiment, but let's walk through what you need just in case. You're going to need 2 glasses that are the exact same size. These are just 2 glasses from my cupboard. Then we're looking at some food coloring. We're just talking some red and blue food coloring. That's all you need. A plastic sheet, that can literally be anything. Take it out of a board game. I just cut a little sheet from a photo album actually as my plastic sheet. Anything will work. We're doing this at home, so whatever you've got works. You'll need some water and you're gonna have to heat some up. I'm actually gonna take some water from our Brita in the fridge so we have some cold water as well. You'll need that nice difference in temperatures. The colder and hotter you can get, the better. And just a dish, and the dish is just gonna be used to help as a spill zone because this can be a little bit of a messy project. Okay, so at this point, hopefully you've gathered all that you need for this experiment. If not, you can redo the experiment by replaying this video afterwards. I'm gonna get started so we can go through the experiment and what it all means. First thing that I have to do is make sure I've got hot and cold water. Like I explained, you want the hot as you can get and the cold as you can get. So I'm gonna take a second here and I'm gonna go microwave some water to heat it up, and I'm also gonna get some water from my fridge. Take a moment. So now we have our hot and our cold water. By the time you bring them over and put them in your spill pan, if you forget which is which, you can just give the glass a touch and you'll be able to tell the difference. This is my cold water, so I'm going to add blue food dye to it. That's the first step, is differentiating your 2 air masses with your different colors. So I'm adding my blue food dye into my blue water. You can go ahead and give it a little stir with a spoon so that you've got that color all the way throughout. After that, you're going to add your red food dye to your hot water. So here we go, adding a few drops of the red food dye. You can add really as much as you want, however deep you want that color to be. Stir that one up. Okay, now you've got your cold and your warm. The next step is the trickiest part. So here we go. And before we do it, here's a heads up for you. The reason you've got this spill pan is because you're probably going to spill. Now, I've actually taken that plastic sheet that I had and added a little bit of cardboard to it just to try to make it a little more sturdy. Whatever you've got's gonna work. You just might spill some of the water out. Whether you have a full glass or a half glass when you do this is not gonna be the end of the world. So don't be too upset if you spill some out. I probably will here in just a second. So we're gonna start with the blue water, and make sure your water is filled all the way to the brim. It's okay if it's even kind of bubbling over the top a little bit. You're gonna add your little card to it and kind of push it on so that you've got it nice and suction. Now this is the tricky part. You actually need to flip this glass over using your card as your shield, and then you're going to connect it to this glass, your red or your warm glass. Like I said, might spill. Here we go. One quick flip. There we go. Not too bad of a spill. Now you want to make sure you line the glasses up as perfectly as you can, because remember, you're going to pull this card out rather from the cold air. So I'm going to try to line my glasses up perfectly here, and we're going to give it a go. Okay, so I pulled this out. What happened? Pretty quickly, what was once blue and red, or cold and warm, became purple. Do you have any guesses as to why? The answer is all about density. We'll get to that in a second, but I want to reverse the roles. I want to redo this experiment and see what happens if we would put the warm air on top and the cold air on bottom. So let's take pause. You can reset your glasses of water, add the new colors of food dye, and then we'll get back to it. So now I've reset our experiment, meaning I've refilled our glasses of water. I've got our cold glass of water and our warm glass of water, and I've already added the food dye, so you should do that too if you haven't done it yet, so that again you've got red for the warm water and blue for the cold water. We're going to flip the experiment, so instead of adding the blue on top of the red, this time we're going to add the red on top of the blue. Take your guess as to what you think happens. Will it mix again, or will it maybe stay separated, or will they flip spots? Let's take a look. So you're going to grab your plastic cardigan, and remember, you can do whatever you need for the plastic card. This is just some cardboard that I stuffed into a photo album sheet. So you're going to take your plastic card, and this time you're adding it to your red water. Again, a little bit's going to spill out. That's no big deal. You're going to kind of suction cup it on so that you can feel it pressed right up against the glass. And then you're going to slowly and carefully give it a flip. So I'm spilling just a tiny bit, but that's not a big deal. All right. So remember, you want to line up your glasses perfectly. And then you're going to, as quickly as you can, there we go, pull your sheet out. Take a look at what's happening. Did they mix? No, they didn't. Instead, you still have your blue at the bottom and your red at the top. Pretty cool, huh? And if we stand here and we wait, well, we see a little mixing zone right between the two glass lines. They really aren't mixing. I can touch this glass, it still feels hot. I can touch this glass, it still feels cold. Take a try at home too. So, the big question is, what's going on here? Why aren't they mixing? Let's talk about it and explain it in terms of how we forecast the weather with cold fronts and warm fronts. Before we get to that, go ahead and clean up your station. You don't want to spill everything all over, so go ahead and get rid of this, and then we'll talk more about the explanation as to why this happened. Okay, so let's get to the science behind this. What just happened with our experiment? We're still looking at our glasses. I've made sure they're leveled up so they don't spill, and the blue is still separate from the red. Well, this all has to do with density, and while we used water for this experiment, the same conditions apply when it comes to air masses, both warm and cold air masses. So here's the deal. A cold air mass is more dense. It's thicker. Warm air masses, surprisingly, you might not think this, but they're actually less dense. So when we had the blue, cold, on top of the red, warm, that heavier blue, cold water wanted to sink, and we mixed to a purple color through all the glass. Now that we have the warm, less dense water on top, or air, it's not mixing as easily. That's why you have the separation of red and blue. It's all about density. So what did we learn from this? Warm air, less dense. Cold air, more dense. And that can impact things like baseball. It impacts cold and warm fronts and how they bring us weather. And let's get to the details on that. That's up next. First, cold fronts. So cold fronts are interesting because they're the ones that bring us the really active stormy weather sometimes. When you hear us tracking a cold front, usually we're tracking the more severe activity. Why? Because that's the more dense air. So when cold fronts ram into warmer air, it's a quick impact. They're quick moving, and quickly that warm air is forced up. Well, upward lift can trigger things like storms, clouds, rainy weather, usually in a thin band. So sometimes when we track a cold front, it only lasts for maybe 30 minutes or an hour before the storms are gone. But it's quick and it can bring stronger stormy weather. It's a little different when a warm front moves in. Warm fronts moving into cold air, because they're less dense, can't pick up that cold air and slam under it the way a cold front does. Instead, what happens? That warm air starts to stack on top of the cold air. And as it stacks, it brings cloudy conditions, sometimes foggy conditions. Showery and rainy weather is possible too if there's enough moisture. That's what you'll see happen with a warm front. But it's slower moving and the impacts can be longer lasting. So warm and cold air masses play a big role in how we forecast as meteorologists.
Hopefully you learned something. I'm so glad you're able to tune in. And if you have a chance, try it out at home yourself. If you're interested in more weather experiments like this, you can go to our website, NBC10.com, and search Weather Education Week. Thanks, guys, and enjoy this virtual event.
You can be